these sections, we're going to talk about measure of dispersions. And measure of dispersions are used to describe the spread of data item in a data set. And one way of showing dispersion is the range. And we're going to look at the range. And also we have standard deviations. So those two items that we're going to look at in these sections. So first, we're going to talk about range. Range, we know that range is going to be different between the highest and lowest data value in a data set. So in order to find the range, you're going to do highest data value minus the lowest data value. So example 1 is asking you to find the range of the given set. So we have a sample of price paid for last haircut with tips included. And so we have $10, zero amount, $0, and 15, 30, 20, and so on all the way to 5. So with this set of the data, if we wanted to find the range, we need to be able to find highest values and lowest values. And sometimes if you cannot locate that, you need to rewrite it from the smallest numbers to the highest numbers. But we have a smaller set here, so it's easy to find. We have smallest number of 0, and look like the highest number is going to be 120, right? So we will do highest range is equals to highest minus lowest. So your range is highest 120 minus lowest 0. So it will be 120 of your range in this given data set. Example 2, we're going to see if we can find the standard deviations. Standard deviation for the following sample of the length in minutes of 8 consecutive cell phone conversation by one person. So we have 2, 8, 3, 2, 6, 11, 31 minutes, and 9 minutes. So with these numbers given, in order to find the standard deviations, we need to go over all these steps to find the standard deviations. So first thing, what they're saying is that find the mean, right? Find the mean, and then do the data minus mean. So each data, you need to use each data to subtract the means, and you're going to square that number. And then this means finding sum of that square, right? And then divide that by number of data minus 1. And when we square root that, that's going to be our standard deviations. So let's go through that. So first thing I need to do is finding mean. So if we wanted to find mean, we're going to add all this data. Divide that by the number of the data, which is 8. This gives you 72 divided by 8, which is going to be 9. So your mean is 9. So then what I will do, I will like to write little charts so I can do each data subtract by mean. So I'm going to start writing this sample data on a vertical way. So that's the sample. And then I'm going to subtract each data by 9. So I will do 2 minus 9, which is going to be negative 7. And then I'm going to do 8 minus 9, which is negative 1. 3 minus 9, that will be negative 6. 2 minus 9, that will be negative 7. 6 minus 9, that's negative 3. 11 minus 9 will be 2. And then 31 minus 9 is 22. And 9 minus 9 is going to be 0. Because 9 being a mean, if we're going to end up adding all this number, so negative and positive, at the end, the total of this value right here is going to be 0. So we cannot add this value because it's going to give you 0. So that's the whole reason, because we need to have the numbers that we can play with instead of 0. We're going to square that, and that's the what? That's step 3 right here, right? You're going to square that. So when you square negative 7, you get, so you're doing negative 7 squared, you get 49. Negative 1 square, you get 1. 6 square is 36. 7 square, 49. Negative 3 square is 9. 2 square, 4. 22 square is 484. And you get 0 square of 0. So now you're going to total that, right? So find total. So you're finding summation of those values. And that's going to be your number 4 steps, right? And that is going to be 632. So now what you need to do is, if we're looking at the next step, we're going to trying to find the standard deviations. And standard deviation come from square root of that summation value, which is 632 over the number of data minus 1, so it will be 8 minus 1. And this is going to be square root of 632 over 7. Again, that looked like square root of 90.2857. And when you square root this is come out close to 9.5019 minutes. And that's how you're going to find standard deviation by the steps. So that's standard deviations. And we found that by going through these 6 steps. Right? Going through these 6 steps. First, find the means and subtract mean from each data and square that value and find the sum of that square and divide that by number of data minus 1. And when you square root that, right? When you square root that, that's going to be your standard deviations. And we have another way of finding the standard deviations. We call this short way. And I'm going to give that shortcut formulas. So your standard deviations is going to be found by square root of summation of, this is x is going to be stand for mean, square minus n times, n is the number of data, times x, your mean squared, right? Divide this by n minus 1. So here in this problem, we know what mean is equals to, that's going to be 9, right? And we know what n is equals to, that's going to be 8. So only thing that we actually need to figure out here before we plug into this shortcut formula, we need to figure out summations of data square, right? So summation of data square means each data you're going to square and then add them, right? So first data is 2, so you're going to 2 square. Then second is going to be 8 square. And 3 square plus 2 square plus 6 square plus 11 square plus 31 square plus 9 square. And that's going to be sum of data square. And when we get that value out using your calculator, you get 1,280. And when we put that into the formula here, we're going to get standard deviation equals to square root of 1,280 minus 8 times 9 square over n, 8 minus 1. And this gives you square root of 1,280 minus 9 squared times 8 is going to be 648 divided by 7. And this is going to give you somewhere close to 90 point, well, square root of 90.2857. And if you wanted to compare that with the other work we had, it's exactly same value. Not always you're going to get this exact value when we're using the shortcut. If we have a small number of the data, the value is going to get more close when we're using the shortcut. Okay. If your data is larger, this difference is going to be more. But right now, because the data is small, we have about the same value. And we know this is going to be equals to 9.519 minutes. So either way, that your solutions, which is standard deviation, will be 9.519, right? From the example 2, we learned that we have 2 ways of finding standard deviations. And we also learned that if we have a smaller data set, then we could use the shortcut, right? So I'm going to write down that formula again. Since it look like I have small number of data, I only have 5, right? So that's going to be square root of summation of data square, then minus n time mean square over n minus 1. So I know my n here is going to be 5. And we need to find the mean, right? Our mean is going to be adding up the data divided by number of data, which is 1050 divided by 5. So your mean is 210. And what else do we need to know? We need to know also, we know n minus 1 is going to be 4 then, right? And we need to know the summation of data square, right? So that you're going to find adding up data square. Adding up all the data square. And this is going to give you 349,350. Pretty large numbers. So let's see if we can replace that. It will be 349,350 minus 5 times your mean is 210 square all over n minus 1 is 4, right? So then 349,350. So 210 square times 5, you're going to get 220,500 over 4. This is going to be square root of 32,212.5. And when you round this, you get 179.5 miles. And that will be the standard deviation for the given data example 3. Example 4 is asking if two classes have identical mean score, but one class has a standard deviation 3 times that of the other, which class is easier to teach and why? Solution is that smaller standard deviation is easier to teach because there is less variations among students. Let's think about it. If teacher is teaching the class with the bigger deviations, if teacher is giving problems that's more to the students that's the lower part of the grade, the people who got high grade, they will be bored because they already know that material. They already score high. But if you're going to level your lecture into the student with the higher grade, then the student with the lower grade will be confused, right? They will not understand the material. So it's hard to teach when you have a bigger standard deviations, bigger different gaps between two students or two groups of students.